Yo, yo, yo. What's good? What's good, everyone? What's good? Let's tweet this out. Happy Pi Day. Happy Pi Day. Happy Pi Day. Is this the right link? It can't be the right link. Let's just go here. It can't be the right link. Let's just go here. It can't be the right link. Let's just go here. I'm live on Pi Day. Link. Wait, we got an Elon Musk meme here to check out. Let's take a look at this. Singularity. Oh, really? It'll be great. Y'all see this? Y'all see this? Okay, I think that's max zoom. Okay, it looks normal. All right. So, Pi Day. It's Pi Day, everyone. Everyone, put your pies in the air. Pi. Happy Pi Day. Happy Pi Day, everyone. Happy Pi Day. Happy Pi Day. Okay, so today on Pi Day, I'd like to do something fun, which is to actually find out what pi is. So that's what we're going to do here today. And I'm going to use this new application I just got, which is called a Freeform. It just came on my newest Mac update. So here's what we're going to do. Let me show you guys what we're going to do. So we're gonna write some Python code to estimate pi. That right? That's what we're gonna do, guys. That's what we're gonna do. This right here. This is what we're gonna do. How are we gonna do this? That is the question. Okay, guys, this is how we're gonna do this. This is how we're gonna do this, guys. Guys, are you listening? I hope you're listening, because I'm gonna show you how we're gonna estimate pi. We're gonna do it before midnight Central Time, right? You with me? I know you're with me. Okay, so I'm gonna show you guys how we're gonna estimate pi. And this is the visual diagram I am creating to help us estimate pi. Boop. Okay. So we have basically what I have drawn here. I'm just trying to get the dimensions. Oh, that's the best we're gonna get it right here. So what do we have right here? We have a circle inscribed in a square, okay? And we're gonna write some equations about this right here. So the surface area of the circle is what's the surface area equation? Anyone? Can someone shout it out, please? Because that would be extremely useful, or else I'm gonna have to just sit here and think until I get the equation in my head. Let's think here. What is the equation for the surface area of a circle? Well, the circumference of a circle, pi r squared, the circumference area is pi 2 pi r. Here we go. It's coming back to me now. Let's write this down. Circumference area of a circle is pi times r times 2, right? So also known as 2 times pi times r. Otherwise, r could just be converted into diameter. The surface area of a circle is going to be pi times r, right? R meaning radius, right? Obviously, squared. That's the surface area. See, it just came back to me. That geometry knowledge. I just had to sit on it for a second. Let's make this font a little. Oh, way too big. Way too big. Way too big. Too big. Too big. That's big. That's good. I like this. There we go. Okay, so what we're doing here basically, like meta-analysis. So we're basically just having fun on Pi Day, guys. Having fun on Pi Day. And we're just gonna use this at Freeform. We're gonna design this problem. We're gonna estimate pi. Why are we estimating pi? It's Pi Day. That's why. Don't ask too many questions. Just waste of time. Waste of time to ask too many questions. But we gotta get a move on. Almost 6 of the way through the hour. How have we gone so far? We got the equations here. Surface area of a circle, circumference area, jeez. Circumference of a circle. We'll leave it misspelled. So the focus, let's get back to the main point. The excellence of pi. We have to estimate pi. How are we going to do that? Well, our past selves gave us this visual example here. So let's decode how exactly are we going to use this circle inscribed in a square to figure out what pi is. Well, okay, here's the idea. Here's the idea. Follow me through this idea here. Let me spit out the idea. We have darts. Darts. Darts that we throw at this figure to our left. This is the figure right here. Alright guys, I'm gonna have to pause real quick. I'll be right back with the continuation of this. Oh my, my sincerest apologies. Sincerest indeed. Family dilemmas. You know how it goes. Lush in the building, guys. It's Pi Day. Let's get back to it. What were we doing? Optimal body posture here. Let's go back to our freeform diagram. So, we were talking about writing Python code to estimate pi, and so what I'm asking you guys, so how are we going to do this? Here's the cheat code. Let's imagine that we throw darts at this. This is our dartboard right here, and just imagine we're throwing darts at this area, okay? And what are we going to do here? Let's add some visual tools here. Line. We're going to add Mr. Line here. Mr. Line is going to sit right here. Ooh, I am loving this freeform shit. Oh, excuse the profanity, but ooh, that snapping is sexy. My God, by golly, by Jove. Okay, we got a target there. Okay, we have this target. We're throwing darts at this target. And these darts are gonna land in these coordinates. They're gonna have coordinates, obviously, because this is a coordinate grid. Haha. So this point right here, for example, is 0, 0. How are we gonna mark those points? I mean, obviously a small circle, a very tiny circle. Um, that is the size of black. See, that is a dart at 0, 0. We have one here at, let's say this is like 0.4, 0.7, right, you know, like almost, right, or we have, so I know y'all are following right now, but we have these darts, and I'm just kind of thinking about the specifics math of how we're going to do this. Because I'm sure you guys see where we're going by now. Wow, what I want you to imagine is that we throw a whole bunch of darts at this. Like a whole bunch. Like, just like boom, 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 boom. Oops. Boom. These are a lot of darts here. We're just simulating dart throws. Throwing darts, right? We're throwing darts, okay? We're just throwing darts. Okay. We threw a lot of darts. That's a lot of darts. That's a lot of darts. So now what I want to think about is how are we gonna pull out pi from this assortment of dart throws, right? These dart throws are on this coordinate frame. Let's just say that this coordinate frame goes up to 0.5, right? This goes up to 0.5. It's still at y equals 0, and it goes back to negative 0.5. Okay, so that means that this circle has a radius of 1. Um, and it's just something to keep in mind because, it's always good to know the radius of a circle you're working with. How much time do we have left? Oh my god, we are halfway to the end of the day today in Central Time on Pi Day. So let's get to it, boys and girls. Okay, so darts we throw at this figure, they are going to have coordinate values between the x and y values of 0.5 and negative 0.5. So how are we going to extract pi from that? It's very simple, boys and girls. It's very simple, actually. How we're going to do that is, let's say we have a throw number x lands at, let's call it something else. Throw number 1. Throw number a lands at coordinates x, y. Okay? Let's generify this. Lands at x, y. Um, what can we do with x, y? Well, one thing we can do with x, y is apply it to the distance formula, right? What's the distance formula? Let's search up the distance formula. Boom. Distance formula. Images. Oh, there we go. Distance formula. Hope you guys can see this. X squared minus x1 squared plus y2 minus y1 squared. What does this tell us? It tells us that what is the distance formula? We give it one set of coordinates and two set of coordinates, two sets of coordinates, one xy value, two xy value, and it tells us the distance between those two sets of points in a 2D coordinate space. The distance formula can also be genericized. Use that word twice in that live stream. Made up word. Into any kind of dimension that you're in. So let's copy image, paste image. Beautiful. Thank you, freeform. We have the distance formula here. And what we're going to do with the distance formula is find the distance of it from the origin, which is 0, 0 here. How much time are we at? We are doing pretty good on time. Given this explanation, we're just going to have to give enough time for the decoding part. But okay, so we have this equation here, and this is obviously equal to the distance, which is a singular value. So x1, y1 equal to 0, x2 equal to 0, and y1 equal to 0, and x2, y2 is going to be equal to x and y of the dart. Right? So that's what we're gonna do. So if we plug in, we're gonna plug in x for x2 and 0 for x1. So x minus 0, that's just x. So x squared plus y minus 0, that's just y squared. That's just y squared. So x squared plus y squared. So square root of x squared plus y squared. That is going to give us the distance from the origin of the dart throw. So square root of x squared plus y squared equals distance from the origin, right? Okay, So we got this, right? So we know the distance from the origin. So let's keep going. Let's keep going, right? So, so the distance from the origin, if the distance from the origin is less than or equal to, what's the radius of the circle? See, this is where I'm debating. I I don't know if you guys could tell, but I just went into a serious, like, introspective thought there on what the radius of the circle should be for our code simulation. Those kind of thoughts really snap me out of the work I'm doing. Um, but the radius, should the radius be 1.5, man? Just what I'm thinking about. I think the radius should be 1. You know what? I'm feeling that right now. The radius should be 1. So before I write that sentence, I'm just going to change these numbers here. So we have 1, 1 here, -1 here. We have a, I see, that wasn't too hard. I don't know why I was thinking so hard about that. So if the distance from the origin of the dart throw is, if the distance is less than the radius, which is equal to 1, then the dart landed inside the circle, right? So now let's develop a ratio, guys. We are almost to the coding part, and I'm definitely going to have to take another bathroom break momentarily, but let's just write out this ratio first. So the ratio is if, okay guys, it's gonna have to, bathroom break is happening right now. Momentarily. Okay, y'all, I'm back. It's 11:40. Time is of the essence here. So we're talking about the ratio of these dart throws, and what I was going to tell you is that the ratio of the number of darts um, in circle, otherwise, the number of darts over the number of darts thrown is going to be equal to in with given enough darts thrown is going to be approximately equal to surface area of circle over surface area of square, right? Um, Given darts are thrown with x and y random between -1 and 1. So that's essentially where we're going with this estimation of pi, if y'all are following. Yeah, so now we can like just put in these equations here. So what's the surface area of a circle? You had this equation here. Surface area of a square is just going to be, well, in this case, one side is 2r, so we'll just do 2r squared, which this would seem to simplify. Anyways, it does simplify, obviously, but that's not the point, right? We're trying to solve for this god dang variable on Pi Day. Ha ha ha, almost forgot the point of this exercise. Um, so, this is equal to the ratio, obviously. So the ratio divided by pi, or no, sorry, we leave pi there. The ratio times, jeez, need some parentheses here. We have pi times r squared divided by 2r squared, pi r squared divided by 2r squared. So the ratio times 2r squared, we remove this, right? Because we just multiplied it times this side. Then here we divide all this by divided by r squared. See, we're just doing algebra in free form right now. That's all we're doing. See, pi on this side. What's the time? 11:45. Jesus Christ. That's gonna be a real test of skill. We can always switch to mountain time though. was thinking about that when I was in the bathroom. Ratio times, so we simplify this. R squared removes, R squared removes. That means that the ratio times 2 is equal to pi. That's a crazy moment right there. Let's code this bitch. Excuse the profanity. Okay, not even gonna save the file until we finish it. Def um gotta save the file. What am I thinking? Let's go to my projects folder, new folder, Pi Day, and we're gonna call this Pi Estimator dot fudge, not dot txt. Okay, let's go and fix that. Hopefully you guys don't see my secret files. Pi, use pi. Okay, we're looking good. We're looking good. Let's go ahead and give a little more promo to this before we actually start doing the coding aspect. Let's go ahead and give a little more promo to this before we actually start doing the coding aspect. Let's go ahead and give a little more promo to this before we actually start doing the coding aspect. We're looping. Alright. Looking good. Looking good. Very good. Very, very, very good. How do I write Python code? I'm forgetting. Print. Obviously, I want to make it writable. Print hi. Hi. Okay, let's try to get this. What is going on right now? Where is this file saved? Jeez Louise. Not sure what's going on there. Okay, projects ls pi day. Oh, put space in the folder. Much better. Okay. Pip env shell. I'll go to my shell editor. So now I'll throw some darts at our simulation. So let's go ahead and Google some documentation here. Python random number generator. Here we go, docs.python. Haha. Oh, that looks horrible. Okay, how to generate a random number in Python. Ha 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 ha. Import random. Rand int 1 to -10. Seems pretty simple. That seems very simple actually. So import random dot rand int. We want a random integer from -1 to 1, and that is going to be our x value. Our y value is equal to random dot rand int from 1 to 1, and we are going to do this for x in 4, I in range, for dart throw, because we are constructing a loop right now. We're gonna want to do this multiple times, so in range, and this number is going to tell us our how well we're going to approximate pi. And we're also going to want to define these variables outside the no, not those variables specifically, but we're going to want to define the ratio or something outside. I don't know exactly. I'm jumping ahead of myself. We're doing okay though. It's 11:51, 52, 8 minutes. Let's see how we do. That rhymed. Um, that was sexy, but I won't get caught up in that. For dart throw in range, 100 dart throws. Our x coordinate, our y coordinate, our ratio. No, we can't do a ratio yet. The distance formula. Forgetting our. Get rid of this. We need to find the distance formula, so we need to import numpy as MP. Just got rid of the Safari. Numpy square root. That is going to be np.sqrt. So np.sqrt x to the power of 2 power Python power. So do np pow x2 plus pow y2, right? So that's the distance from origin if distance from origin is less than or equal to 1, which was radius of a circle. This is already defined this variable. Throws equals. Ooh, this is where we can do this. Throws. Dart throws. Side circle equals 0. Side circle plus equals 1. And then after this loop, ratio dart throws divided by dart throws, and what did the freeform say? Freeform said ratio times 2 is equal to pi. So print ratio times 2. Well, I guess let's try it. I have no idea why it's asking me these questions. these. Why can't it save this? That is so weird, man. But let me just copy this code. Don't save. Let's reopen this file. Just don't know what's going on there. Open with BB edit. There we go. Okay, it's normal now. Okay, let's clean this up a little. We're in our pip shell, pip env install. Wait. I need to edit the pip file. Okay, I can do this. Boomlands BB edit. Okay, let me show you guys some other shit. Excuse the profanity. But I'll use this to same kind of formatting to add in random and numpy, right? Yeah. Oops. Okay, I just ran a pip env install. Looks like we're installing the. Oh god. Oh god. Oh god. What's going on? Get rid of this one. Haha. Okay. We're good. Python estimator. What's going on? Wait. It estimated pi. 1.06. That's not right. That doesn't seem right. What? Oh god. My day is ruined. What the fuck? Ratio times 2 0. Oh my god, am I gonna have to troubleshoot this? Oh my rip. Oh, they're not decimals. They're not decimals. I'm not even gonna bother to narrate because, like, I hate stupidity. Why? No, I have no idea what's going on. Oh, this is obviously not right. See, we have to do um minus 0.3.5. Right, we shifted 0, 1, back 0.5 times 2 goes to 1. Yeah, that seems right. Minus what? God damn it. Um, so random dot random, random dot random, random dot random, random dot random returns a random float number between 0 and 1. Oh, random dot uniform returns a random float number. I'll try using that. It's lasagna. What? Okay, those are obviously random numbers. Oh, obvious problem. Guys, it's integer division. Okay, that wasn't the entire answer, I guess. What? How did I do this algebra? Ratio divided by, no, times ratio 2 times r squared. This is expected to be the ratio times 2. Oh my god. Jeez. The mysteries of pi. The mysteries of pi. It's just the mysteries of pi, ladies and gentlemen. Let's just go ahead and estimate this. It's the mysteries of pi. You know, even when I was a little kismet, I think I had the same problem when I was trying to code this problem. Wonder if this is ever gonna finish. I did put a lot of zeros on there. Well, I guess let's see how many viewers we have. One person watching. Who the fuck is watching this? She's a profane. One person watching. Who the fuck is watching this? She's a profane. One person watching. Wait, maybe that's just me watching. Well, Pi Estimator is still going, so I guess I'll just let this thing go. I'll leave the screen on it. I'm gonna turn my webcam and my mic off. We'll see if it finishes, though. I'll hop back on if it finishes. Yo, I realized I'm only using one CPU. I'm only using one CPU on my Python performance. I didn't multi-thread it. That's why it's so slow. Regardless, figured we should play some Kerbal Space Program. 'Cause that's what that stream was about. Wow. Bobby Wop. Observe mystery goo. Keep experiment. The nav all go away. Ooh, we are about 10,000 feet above the lunar surface. We're hitting our apoapsis about now. Just hit it. Now we're plummeting straight down. Well, our first launch of the popper, I would say it was a success. So now we are waiting for a successful landing here of Jebediah Kerman. See what he is seeing inside the spaceship. Holy crap. This is a pretty scary view. I'll be real. Seeing no tracking on the radar altitude. Just see us coming in here to the coast. See here. So C takes me back to this view. We are coming down. Just let the nav ball go away. We're coming down fast. Are we gonna get parachuted? Here are the parachutes. Gauging, slowing us down, flipping us right side up, coming in for a smooth landing. Let's physics warp this down to landing. Okay, and recover vessel. There we go. Got some science. Just did our first flight. 26 science. Got some funds back. Let's go to the R&D facility. 26 science gives us engineering 101. Decoupler. I think we'll definitely need this. Definitely need this. F16. Might as well use this. Okay, nice. Let's go ahead and take on take this one. This one feels good. We can do that. We will test the fleet indeed. So have Mark 16 parachute, curb and flying altitude, and then just going some sort of speed upwards. And then we also want to test the flea. So we have the flea hooked up. So we can take this one to 2,000 altitude with a Mark 16 parachute. We have the Mark 16. Okay, so we can just take this vehicle then. And then I guess we'll aim it to go over the water. Let's just try that. Okay, here we are. So I'm gonna do the D key to go towards 90 degrees. First we're gonna run the test of this. Okay, there we go. And let's just pitch to the right here to get distance off to the right. Now, probably landed. Yeah, we're definitely gonna land in the water. Check the map here. Yeah, we are definitely going in that water. Okay. So, I guess let's do an observe mystery goo. Keep the experiment. Do a crew report. Keep the experiment. Coming down to engage the parachute. Check our mission. Oh, we are good with our contracts. Engage the parachute. Okay. We are coming down here. Coming down here for our second flight of Popper. We are landing it for recovery. Back to time warp of 1, and we are coming in for a nice clean splashdown here. And we have splashed the vessel. Oops, we'll do another observe mystery goo. Keep the experiment and recover the vessel. There we go. More science. More science. Love playing KSP, guys. Next. Done. Research and development. We're at 16.4. Well, these all cost a little extra, so we're gonna have to take on another mission. Hammer. So that one was a little tough. We've a test. Shield. This is asking us to test the heat shield splash down. Let's take that one. How about we just stick with that contract right now? Okay, so to do this contract, we're gonna need to add a 1.25 meter heat shield. And we do have a decoupler here. Okay, so we're just gonna scrap away the popper. Well, this is the popper too. Save it. Throw away this fuel tank. And here we have our thingamajig, and we're also going to add a communicatron. right there. Ooh, there we go. Now we can communicate to our people. There's some new science here. And a thermostat back here as well as a thermometer. Okay. Then we have the two coop containers, which I think we can just get rid of for now. Because we won't need to carry those goo containers everywhere we go. Got a lot of goo data. Okay, this looks good. Payload, don't need anything there. Don't want Xcode right now. Why would they give us a liquid? Oh, I guess because they gave us shit things. Okay. So, let's just go ahead and build a first stage. To do that, just gonna need a bunch of these. Bunch of fuel tanks. Seems like enough fuel tanks. 1, 2, 3, 4, 5, 6. Fuel tanks. Does this even take off? I really doubt it. But, okay. I hope so, at least. Call this Popper 2. And I don't even have any. Decouplers, so just gonna launch it, get some data, get some science. Hopefully we will recover Jebediah, though, so that is always the priority. Oops. Okay. Let's get a temperature reading, log the temperature, transmit the data. Crew report. Reset that experiment because we didn't get anything out of it. Log the pressure data. Transmit this. Okay, not enough charge. That is fine. We are go for launch. Throttle up to 100. Turn on the SAS. Let's launch. Whew, we are getting some serious delta V out of this. Wow. Okay. Let's conserve the fuel that we have to a solid cruising altitude of 100 meters per second. We're going to start our tilt to the west east. Excuse me. Still have plenty of delta V here. We are looking good on this flight. Going to a more steep incline. I'm gonna throttle down a little more to a steady 300 meters per second as we exit the lower atmosphere. And we are at a full 45-degree tilt right now. We are going to throttle down more, and we are at almost a 1/3 throttle right now. This is a very nice flight. I'm excited to see what our apoapsis is of this flight. So as we are exiting the atmosphere, I go ahead and throttle up to a more maximum here. Here's full throttle right now. Burn out our components, but before that, our fuel on out. Our fuel out. Holy shice. Just had an explosion of our thermostat. Rip. But we are in quite an elliptical, right, or quite a suborbital trajectory here, going quite fast. Apoapsis actually going out of space right now, so we will be able to take measurements in space, which is very exciting. That is quite a lot for our first expedition here. Very promising. We can see our launch site right there in the distance. Let's turn off the SAS and position ourselves here. And now that we are at almost 60 degrees, let's go ahead and decrease. We are left with our capsule here. And let's go ahead and get this to our retrograde direction. There we go. We're at our retrograde. And almost in space now. We are in space. Let's go ahead and take a crew report. Transmit. Ooh, we have made a transmission. And we can go ahead and take a log pressure data. We're going to overwrite it. Guess that's fine. Transmit this. We're going to run out of charge. It's alright. So we're coming up on our apoapsis here, and we've got about 1700 meters per second of vertical velocity. We're basically coming up on our apoapsis. Say that's about halfway to orbital velocity. Let's see how our boy Jebediah here is looking. Nice and pretty. Nice and pretty indeed. Let me get this in a little bit of a spin. Jebediah, are you there? Huh. I don't have any more control over the spacecraft, which is a little concerning. Is that because we're just outside of atmospheric control? I'm assuming so. It's okay. We're at a good prograde angle, or I mean retrograde angle, coming into re-entry here. So I think we'll be good. You can see our debris there, floating off in the distance, but it's just quite a good launch attempt. And I think the science that we will recover from this, it'll help us progress on to our next launch vehicles, and we can catch up on the science that we missed from this flight and continue more suborbital flights and actually other directions too. So let's go ahead and do a time warp here, coming into re-entry. So yeah, we're coming into re-entry here. Let's see if we have, okay. So we're regaining some atmospheric control here. Let's go ahead and reposition ourselves in our prograde angle. There we go. So we're coming in here to our prograde angle, and we have our mission contract also. So it's asking us to test the heat shield splashdown. So right now we are on a trajectory to be landing in the ocean, depending on atmospheric drag. We will see how that goes, which should be receiving about now. Here we go. Here we go, guys. Here's our craft. Let's turn off the SAS here. Velocity now. Now we are just waiting to deploy our parachutes. It does look like we are not going to have a water landing, unfortunately. Yeah, I do not believe we will slow down fast enough for that. It was a valiant effort coming into this, into the landing here. Yeah. Well, at least Jebediah is alive, which is all that's really important in the grand scheme of things. Cover the vessel, guys. Should cover the vessel, Kerbonauts. Ooh, that is a lot of science, guys. This is looking good for our R&D department. What do we actually need, though? I think we are going to need the thumper. Yeah, I think we're gonna need the thumper, guys. I think that's what we're gonna need. And I mean, we could save up for those. A radial decoupler. Yeah. I think we'll take that too. see how it goes. And with that, let's go ahead and save. I think that's gonna have to call it for this pi day. How's our estimation of pi? Our estimation of pi! 3.141. We were 4 digits accurate. It's quite a while awaiting too. Wow. Well, happy Pi Day, everyone. See you on the next one. Bye bye.